Okay, so good morning everyone. I am going to demonstrate to you how to solve question number 10. So here's the data set we have. I hope you have corrected this particular data on this row 8. You have to interchange yung sa row 9 yan. Right, so if we want to calculate for the average time using Excel, this time values, it means in actual experiment guys, okay, katulad niyo gikuha ang time, no? So a height of 0.2, just to have a context, no? Our problem is about a ball being dropped from a certain height. So the height in this case is at 0.2 meters. Now every time we drop that ball, we took the time. So let's say time 1 for trial 1, trial 2, and trial 3. From there, we could get the average. So the average, just choose the 3 time, and then here, this button, you click average. On the adjacent column, automatic na maglabas ang average value. And that is 0.197 seconds. It's very important that you have to think of a 3 significant digits based on the significant digits of the source values. What I mean is that ito ay may 3 significant digits, 3. So wala nang mas pinaka maliit na number ng significant digits. So you have to do that, no? Based on what you have learned. I assume that you have learned this already. So of course what we can do here is we could copy that particular cell, itong result natin, and then actually you can drag here, but you can I have to show you na I copied that cell, and then I choose the other remaining cells, and then you paste, but not this one. Okay, you choose the formula only. All right, so that is now our average. Okay, to calculate for the uncertainty, take note that so to calculate for the uncertainty for a repeated readings, note that in our data set, we have 3 measurement of time to a particular height. So to calculate for the uncertainty, we need to use this. We need to use the half the range of the readings. So to calculate for range, what we mean is we have to subtract the maximum value from the data set. This is our data set minus the minimum value. So if you're using Excel, you could do this, no? You could do manually. Hanapin nyo yung pinakamalaking number. In this case, it's 0.198. Then you minus the smallest number, that's 0.196. Take the quantity of that, C3 minus C3. Okay, and then from that quantity you divide by 2. However, if you in our lecture, we have to add the measurement error. In this case, the measurement error we have is 0.001. So we have to add 0.001 plus 0.001, and we will repeat doing the same process sa next na row. So again, you look for the largest number, that's 0.229 minus 0.222. Then take the quantity, take the difference as a quantity, then divide it by 2, then plus the measurement error of 0.001. Okay, you could keep on doing that hantod mahurot ninyo ni. However, here's my suggestion for an automation. Sa Excel, you could do ganito. You could get the, di ba sabi natin range is maximum minus minimum value? So you could get maximum value from a certain data set, then we subtract it with the minimum value from, of course, the same data set. Excel will automatically search for the maximum value and the minimum value. Then it will, of course, subtract. Okay, look at the number of parentheses para it will serve, yung difference will be considered as one quantity. Okay, then you press enter. That. Then what I could do is I will copy the formula, copy, and then I will paste the formula here. I copied and then I paste the formula. So that's our uncertainty measurement. And to get the square of time, simple lang naman. You just get that, then raise to 2. Okay, now to calculate for the square of the uncertainty, we have to use this. Consider this this process. Now in this case, we want to get the, let's consider itong z as our t square. Okay, and of course t square is t times t, right? In replacement nato sa x is a t, then for a y, another t. And to get the value of the uncertainty, we have to use this process. Delta, in this case, it's delta t squared or delta t squared divided by t squared, because we're dealing with the square of time. So it's delta t squared now divided by t squared. Of course, you have to use the delta t divided by t plus the same quantity delta t divided by t. So what I mean is ganito. So first, kunin muna natin ito na sum, ito na expression. So that's equal to delta t divided by its time, ito. Okay? Then take the quantity plus, repeat lang naman kay we're taking the same ano lang naman expression. So balik delta t divided by t. Okay, from that we would get this value. Now this numerical value, that 0.203, is just the sum of this expression. Hindi pa ito na expression. This is what we want. And this is actually our delta t squared. In that case, we have to multiply, just like this here, we have to multiply with our, in that case, dito kasi s, sa ating problem, this should be our t squared. So, yung sum, which is ito, we have to multiply it with t squared. So, yung expression na yan, multiplied natin dito sa t squared na ito. Again, this is not new. It's on the lecture notes. It's just that you have to extend on this particular problem context. But the formula, the same. The principle is the same pagdating sa uncertainty. So, you just press enter. This formula, ito, paulit-ulit lang ito for the other rows. So what we can do is you just have to copy that and then paste. Again, I am giving this demo if you're using Microsoft Excel. I hope the other similar kining mga ubang software nga free kanang ingani gihapon ang kon. But to be safe, please use Excel. This is the first stage sa problem. We complete the table and then we plot a graph. We need to plot a graph of height and the square of time in x-axis. Now, you might be wondering, pwede naman gawin nyo diretso sundugo ng akong instruction, but allow me to plot a graph because allow me to plot a graph nga gamit ang default time and height. Okay, just for you to make sense, the experiment actually is ganito. The time in that sa reality dito sa experiment is the time actually is the dependent variable and the height is the independent variable. However, for this particular exercise, I let you use the time square as the independent variable and the height as the dependent variable. Now, bakit kailangan i-square ang time? Allow me to show to you muna the graph of height versus time. Okay? Height versus time. Hindi yung naka-square. Yung ito lang na value. I suggest you use scatter plot dito sa Microsoft Excel. You go insert, you look for the graph, yung scatter plot ang gagamitin. This one. Okay. Later na lang natin i-arrange yung elements ng graph. Okay? As you could see, first, nagbuot-buot, maguna siya diretso graph. No? First is we have to select the data. Now, once, okay, saan ba i-select ang data? Once you click the graph, you click select data, and then, tanggalin muna yung series na yan. Remove, and then add. Okay? It means this is our for the x values, yung nasa independent variable, as I said, nasa time, yung time. Wag muna yung error, ito yung munang time. Okay? And, of course, your dependent variable is height. So, you choose this. Okay? Then, you press OK. And, OK. As you can see, if we have to extend this actually, this is going to, if we have to extend the number of time in seconds against height, I don't know if it's obvious, hindi masyadong obvious kasi kulang ang data points natin. If we have to extend this, obviously this will form a parabola because a falling object actually is a function of a square of time. Okay, so what you will have actually is a quadratic function. But of course, hindi pa naman natin scope yan. That's our future topic. But this is the very reason why we have to use time square or the square of time kasi po, you cannot make best line of fit kung hindi yan straight line ang graph natin, if this is going to be a half of a parabola. Of course, wala man tayo value na negative time. So, dili gina mo cross dito, no? Dili mo adto sa negative x-axis. And all of the value are on the positive x-axis. Kay ang time is always, in a classical physics, time is always positive. Okay. So, dili na to magamit for this particular exercise ang kinilang ingon aning value of time. I have to use the square of time so that I could make a straight line na graph. Now, let's use value in our x-axis, positive x-axis, using the square of time. So, again, what we should do, you click the graph. So, later na lang na to i-enhance ang elements ng graph. So, let's just plot the data points. You click the graph. Let's change now. Click, select data. And in this case, okay, let's reset. Remove everything. And then, let's add. Dito kayo sa x values. X values natin is the time squared. So, let's use this numerical value. And of course, our dependent variable na sa y-axis is ito, the height. That is, that's how our graph would look like now. So, unless kung wala ninyo ni na interchange ni nga dataset kining naa sa last two rows ha, kini diri o kini. I hope you have corrected the value na interchange na ninyo. So, in this case, you have now data points. Sige, let's enhance the graph. So you could put a title for this graph, scatter plot graph. You may have to use height versus time or square of time, or falling time, no, or say have time, square of time. So in that case, okay, so that's our working title. And then we want to put label there is a iyang x-axis also in y-axis, because numbers, what does these numbers mean, no? So go to axis title. You may have a specific options here, but sabay na natin primary horizontal and primary vertical. For our horizontal axis, we could use time squared. Magun tayo superscript dire, cannot find or back kasi naamoy makita no on your end, but in my end sa Excel, so the unit for time square is of course s square, right? And now for your vertical axis, this is height in meters. Okay, so that's your graph. Now next thing we should do is, very important, is we have to put error bars. What you should do is click these dots, and then you go error bars. If you click kining sa horizontal error bar, you could see options dahil sa kilid sa right side, horizontal error bar. So both, because it's a plus minus, and then what's the horizontal value? Notice that in our data set, look at sa horizontal this is our horizontal uncertainty na mga value. Not that, ito. So we have every set of katong sa height, there is a corresponding error and uncertainty value. Ilahi siya, di ba? Okay, so what we can do, let's go back to our graph. You click the horizontal error bar, and then you go to both because it's plus minus and direction. Then instead of fixed value, kasi iba-iba man, instead of 0.1, you go custom, no? Then specify. We have to look for the positive value. Of course, the positive value, plus minus, the positive value are these numerical values, and press enter. Then the negative value, the same. Okay, so press OK. You could see halos mag-disappear. Why? Because they're very short naman na value na, no? Kita man ninyo ang value daan sa numbers. Those are very small numbers. So the error bars, horizontal error bars, would go short. Pero lahi-lahi na siya ang length ana, guys, ha. Okay, now let's consider our vertical error bar. Again, it's both. However, for our vertical that talks about the uncertainty for height, it's fixed at plus minus 0.01. So instead of going custom, you go fixed value, and then you put number 0.01 and press enter. So that is now the appearance of our graph. Now this time, let us add a line of best fit, average line of best fit for this graph. So what we can do is just click the graph, chart elements, and then you go trend line. Now for the trend line, you choose more options. Then by default, it will create this broken line. That's your line of best fit. I want us to put a name for that trend line, so we will use line of best fit. This is the average, actually. Average line of best fit. Okay, and then next is we want to say that we want to see the equation, so you click display equation on chart. You can see there. We will manipulate later. And then we do not want to see a broken line, so let's use a straight line. So you click this bucket icon, fill in line, and then if you want to choose blue, okay, you can continue using blue, and then here in dash type you use a solid line. Okay, and that's it. That's your average line of best fit. Now in Excel, unlike in the modern Logger Pro software, you could easily add a line, a maximum line of best fit and a minimum line of best fit. However, I tried, in our case, I have downloaded a Logger Pro, but it's quite old version. The new version, I have to pay for it, so I don't have money. In this case, let's maximize Excel. What we can do in Microsoft Excel is we have to we have to identify a specific data points. Now, let's go back to our understanding of maximum of a line of maximum fit. Okay? Maximum line of best fit and minimum line of best fit. In our handout, the maximum line of best fit is a line that will connect the lowest possible value o katong starting nato na point, this point, and to the maximum range. I mean to the maximum possible value, either along Y or along X. What is important is that all of the ranges are covered by that line. So basically, this is a subjective. It depends on us now. In Excel, we can do that by first plotting a line, and then we could appreciate what particular point that we have to identify. I will show you now. Okay, ganito. Now here, let's zoom so that we could see the lowest point here and the highest point there. So if we are going to use a maximum line of best fit, manually, for illustration purposes lang ha, you could use a line and then plot it. Ganito. Starting here, there, and you go up here. Okay. Let me change the color. Color orange shows a maximum line of best fit. We could also indicate the minimum line of best fit. Let's use yellow color, and then let's plot. Add another line here, but this time let's use. Okay, so let's make a new line, and then we will just use have to use yellow color. In this case, this is the line representing the minimum line of best fit, right? By definition, maximum line of best fit is a line with the highest slope among the three, actually, or the steepest line, while the minimum line of best fit, itong yellow, I use the color yellow, has the smallest slope. Now, the problem is, if we just simply use that, we have to calculate for either we need to calculate for the slope of these lines, or let's say for particular line, itong maximum line of best fit, we need to know the slope, and then we could just simply identify data point for a certain x and y. Okay, since we're already using computer, of course you can do that manually, no? You could derive the equation of the line using 2 points. If you could still remember, you could use y minus y sub 1 equals the slope, that is y sub 2 minus y sub 1 over x sub 2 minus x sub 1 multiplied to a quantity of x minus x sub 1. That if you want to do a manual derivation. However, we could use a feature in Excel because it can, of course, make a trend line based on a given data points. Now, the challenge here is we need to know exactly what is the value of that point here and what is the value of this point. What is the data point here for every particular value of time squared and for height s also here. Okay, another is if we could only know the value of, let's say, let's consider ito dito na point, yan, ito, if we could determine the data point here and the data point here. Once we know that, Excel will determine for us the trend line between those 2 points. So actually, we can do that because we know this one, right? This point here. This is just the value of this, which is given. Ito naman, may value ito na certain value of height, right? Then, this is just the measurement. Then we'll just have to add the maximum uncertainty. The same thing also here. This number, it's given in the data point, and then you just subtract the uncertainty value of that number, and you could get the measurement or at least the data point on this part. Here's how we're gonna do that. So let's just delete now all these artificial lines for us. I just use that for you to see what I mean when I say maximum line of best fit and minimum line of best fit. Now, we need to add 2 columns. Here's what you're going to do, no? You need to add 2 columns. I label it as max line for a maximum line of best fit and the minimum line for minimum line of best fit. I just need to know the value of S because the same lang naman ng value ng T yun lahat, di ba? The same value lang. Ang magbabago lang naman ay ito. Ang magbabago lang naman ay yung height. Say for example, we need to know kung saan siya dire. This is S1. I will call this S1. S1 minus its uncertainty value. And the uncertainty value is just 0.01. Okay? We need to know this point and this point so that we could, so that we could calculate for the maximum line of best fit. So, okay, so what we're gonna do is we need to determine, we have to subtract. Ini siya minus 0.01. That's the uncertainty value, right? Okay, and then equal, because that's the lowest point here. Okay, now the highest point is here. This is this value plus the uncertainty value plus, kasi taas man siya. So what we can do is just equals, then this one plus, we will add 0.01. Okay, Now to add, again, once we know the value of our, once we have identified the data points, now let's add that data here in our graph. So right click graph and then select data. Right click, select data. Then this time let's add data a new data series. For, of course, our x value, yung nasa t-squared, hindi naman nagbabago yun. So let's just choose it as is. Make sure na yun pa rin kasi otherwise magbabago yung dito mo sa graph at ayaw mong mangyari yan. For your y values, ito. Okay, again, this is for your maximum line. So isulat mo, series name is maximum line of best fit. Okay, and then you click and it will be displayed here. Okay, the data point. Another is, mamaya na lang natin lagyan ng trend line. Let's load this data. So repeat procedure, right click, select data, then add. Again, on our x values, let's just use the same range for t-square, and then for y, you choose this. Again, ito ang kiniklik ko, yan, para mag-collapse. And then ito. Okay, and then press enter. Okay? Okay. Then click mo yan. Ayun, i-edit natin yan na ito muna, i-edit natin tong pangalan. Tawagin natin siyang average line of best fit. Okay? Ito naman, edit natin. This is the minimum line of best fit. Okay? So, there. And ayan. So andyan na, naka-load na yung mga critical points na yan because we have to just simply connect the two dots. Itong gray na ito to that gray and then orange to that. So how do we do that? Let's just, you go to chart elements, trend line, go to specifics, and then more options, line of best fit muna. Okay. Then, by default, yan ang ginagawin niyang line. Pero gusto man natin solid line, no? So, the solid line should be solid line. And then, the color, it's up to you. For consistency, kasi orange siya. Kasi orange ang gamitin natin na color. And then, it should be a solid line. If you want to increase the thickness or ito siyang manipis, okay, it's up to you guys, no? You can adjust. Hindi ako particular sa design. As long as it's clear that that's the line of best fit, particular, let's say, maximum. Also, for your minimum line of best fit, you go back to trend line, go to specifics, more options, minimum line of, wrong spelling pa. Mamaya na lang i-edit. Okay, so, ano yan? Solid line, again solid line, and then kasi gray siya, so we will use gray. And dash type, it should be solid. And if we want to make it thinner, gusto ko siyang mas thinner for consistency, sa gilid lang. And that's it. Now you have your maximum line of best fit. Now you have the maximum line of best fit and the minimum line of best fit. Okay? So Excel, we know kanina that the trend line could be generated, right? But we have to change this kasi we're dealing with height denoted by S. Okay? And then note that we have number of significant figures, limited lang man siya sa 3. So our slope for this, we should adjust the slope. This part is the slope, right? Ito. That's the slope of our line of best fit. It's just the significant figures, and this is, instead of x, this is t squared, right? T squared. And our uncertainty, our y-intercept, just leave it as one significant figure at 0.0008. It's a very small number already. Okay. Now, we could, of course, request Excel to give us the gradient or the equation of this trend line. Just double click on that. Click on of course, the maximum line of best fit. Go to trend line options by this parang column chart. And then go down, you could see display equation on chart. There you go. That is now the trend line, the gradient for the maximum line of best fit. So again, let's just edit this as, of course, you could, kung manually nyo isulat, is S max. And then adjust the number of significant figures, 3. Then let's have t squared, and then adjust here for one significant figures. We have, so this will be 0.02. Okay. Right, and lastly, for uniformity, another is ito. You could click that trend line and then go back here, trend line options, and then click display equation on chart. And here, change to S, 3 significant figures, 4.6 squared plus 0. Making it 3 significant figure, 1 significant figure, 0.03.